Hello students, in the last session we were discussing about testing. In that we have discussed what is testing, what is debugging, and even we have discussed about test suite, and then we have discussed about a technique to test a software for the bugs. We have discussed the partitioning of input techniques by which we can find bugs in the software. We have also seen an example where we have divided the inputs into some subsets by using the partitioning technique, and then we have studied that finding a good partitioning scheme is very difficult, and that is the reason people rely generally on heuristics based on exploring paths through some combination of code and specification, and based on the paths through the code, we have a technique called as Glassbox testing technique, which simply explores different paths in the code, and one more technique that explores paths through the specifications, and that is called as black box testing. In today's session we will discuss one technique, that is glassbox testing technique. So let's start with glassbox testing. Glassbox testing, it is generally performed by the developer itself, because in glassbox testing different paths in the code needs to be tested, and for that you should have knowledge of coding as well, and that is the reason it is mostly performed by the developers. So glassbox test suites are usually much easier to construct than the black box test suites. There are different paths in the code which needs to be tested in the glassbox testing technique. A glassbox test suite is said to be path complete if it exercises every potential path through the program. If we have a glassbox test suite which explores every path in the code, then it is called as path complete test suite. This is typically impossible to achieve because it depends upon the number of times each loop is executed and the depth of the recursion. So testing every path in the code or in the program, it is almost impossible, because it depends upon the number of times if a loop executes and the depth of recursion if you are using a recursive function in the coding. Even a path complete test suite, if we have a path complete test suite which takes every path in the code, that does not guarantee that all bugs will be exposed. That will not guarantee that all bugs in the code are exposed. So let us look at one example here. So consider this example where we have a function, that is ABS function. So def ABS, and this function is taking one argument x. As you know about ABS function, absolute function, it simply returns a positive value. If we send a negative value, it simply converts it into a positive number and it simply returns it. And there is some specification given about this particular function. Specification says assumes x as int, so whatever argument we are receiving, that x is considered to be an integer, and this function returns x. If x is greater than or equals to 0, this function will return x itself, and it will return minus x, that is negative x minus x. Otherwise, if the x is not greater than or equals to 0, it will return minus x. And the code in this function is, you can see, if x is less than minus 1, if it is less than minus 1, return minus x, else return x itself. If it is greater than that, it will return x itself. Okay, if I have to test this function by using white box testing technique, I have to first construct the test suite. Now, as it is said in the white box testing, in white box testing we have to construct a test suite which exercises or explores all the paths in the code. Now, if you look at this particular function, how many different paths exist in this code? If you look at this function, there are two different paths. When x is less than minus 1, it will take a path, that is, it will execute return minus x and the function ends. And when x is greater than minus 1, it will go to the else part and it will return x and it exits. So there are two different paths in this function. So to test this particular function, I may use a test suite having values, that is where I can take values of x which is less than minus 1 and value of x which is greater than minus 1. If I have only two inputs, then I can exercise all the paths in this function. Okay, the specification suggests that there are two possible cases, that is x is either negative or it is not. So as per the specification, we have two cases or two paths, one for the x when x is negative and other when x is not negative. And this suggests that set of inputs, that is 2 and minus 2, is sufficient to explore all the paths in the specification. Only these two sets of inputs are sufficient to explore all the paths in this particular code. But even though we are exercising all the paths in this code, this will not explore a bug in this particular function. So there is a bug in this particular function. Can you guess what is the bug in the function? So if you look at the code, the only problem is that this test suite will not expose the fact that ABS of minus 1 will return minus 1. So if you look at this function still has a bug, has a problem when we pass a value as minus 1. As per the ABS function, if we pass it a negative number, it should always return as a positive number. But to this ABS function, if you pass a minus 1, this will still return minus 1. And this bug cannot be explored by using the white box testing here. So you can see here, if I pass the value of x as minus 1, so first condition says if x is less than minus 1. So is x less than minus 1? So minus 1 is less than minus 1? No, the condition is false. When the condition is false, it will go to else part and it will return x. So what is the value of x? It is minus 1. So it is still returning minus 1. It is not returning us the value that is 1, that is plus 1. So this is the bug which is not explored in this particular test suite. So white box testing, even though we explore all the paths in the code, does not guarantee that all the bugs are exposed. In glassbox testing, there are few rules of thumb that usually worth following. So the rules of thumbs in glassbox testing are: exercise both branches of all if statements. If we are having if statement in the code, we have to exercise both branches of if statement. If statement generally has two branches, that is one that is for true and another for false. So if we have a if condition in the code, you have to exercise both the branches. We have to find input which uh, exercises the true part of the code and also the false part of the if condition. Make sure that each except clause is executed. If we are having try and except clause in the coding, so except clause, like in Java we use try and catch, in Python we use try and except. So we have to find the input which exercise or which executes all the except clause. If we have included in the coding all the except clause in the code. For each for loop, if we are using a for loop in the code, we have to test cases in which the loop is not entered. Means if we are testing a loop, we have to test it for the values where loop is not entered at all. For example, if the loop is iterating over the elements of list, if we are iterating through the elements of list, make sure that it is tested on empty list as well. So we have to test it for empty list as well if we are having a for loop which is iterating through the elements of a list. Then the body of a loop is executed exactly once. So we have to test a loop. First thing we have to test is loop is not entered at all. Secondly, loop is entered only once, that is loop is executed only once, and then the body of the loop is executed more than once. So we have to pass such a input to the code that in first case the loop is not entered itself, in second case loop is entered only once, and in third case loop is entered or loop is executed, body of the loop is executed more than once. Even in case of for each while loop, if we are having a while loop, look at same kinds of cases when dealing with the for loops. As we have used some cases with the for loop, the same kinds of same cases needs to be even used even in case of while loop, and we have to include test cases corresponding to all possible ways of exiting the loop. So exit condition of a while loop needs to be tested as well. One example is given here. If you have a while loop where length is greater than 0 and not L of I is equals to E. So we have to find such a input cases where loop exits because of length of L is greater than 0, and cases where it exits because L of I is equals to E. So we have to find the inputs, such inputs because of which the loop exits, and even that needs to be tested if we are having a while loop in the code. Okay, for recursive functions, if we are having some recursive functions in the code, we should include the test cases that cause the function to return with no recursive call, then exactly one recursive call, and more than one recursive call. So for recursive function we have to pass values which test the function for no recursive call, and which simply calls recursive function only once, that is one recursive call, and more than one recursive call. Okay, this is about white box testing, or we call it also call it as glass box testing, where the actual code is tested, or you can say different paths in the code is tested by passing some different sets of inputs. And that's it in today's session. We will stop here. Thank you.